pleasure to be here. I love space companies. I've been passionate about space since I was like 6 years old. We were landing astronauts on the moon. And interestingly, in between my flights, I had an opportunity to go back to business school. I became really fascinated with venture and startups. But when I was thinking about this in 2015, what I was going to do with the next phase of my life, I knew there's no way to do entrepreneurship and space unless you're an eccentric billionaire, like Elon Musk and Jeff Bezos. But then fast forward a few years, all of a sudden, because of that increased access to space with a decreased cost, these entrepreneurs were coming up with amazing ideas that were not just super cool, but actually could be businesses that made money. So I'm very fortunate today to have two of those entrepreneurs. Greg gave a great introduction to both of them. I thought I'd start out, Jason and David, if you could just give a quick pitch for all the space novices out here. What exactly do you do? Jason, go ahead.
Well, let me first just thank Kelly and Craig and the Moonshots family for having not just this amazing event, but for taking the vote of confidence in me and in Outpost. That meant a lot, and I promised that we would exceed expectations, and I'm hoping that we're still on that track. So the idea with Outpost is, well, I'll take like a little step back and explain a little bit of my background and passion to frame it. This is my second space company. I sold the last one in 2020. We were building in space manufacturing. We actually built the 3D printer that's on the station that Tim got to operate, so there's a cool backstory there. During that whole time building that company, I was fixated on this interesting point, which is there's huge amounts of money flooding into getting things off the surface of Earth. There's over 180 launch vehicle companies, and there's currently only two ways to get anything back, and that's a Dragon capsule from the space station and a Russian Soyuz capsule from the space station. So technically kind of only one way to get things back for most of the world. And it all has to go to the space station. It's $120,000 a kilogram to do that round trip flight. So like this bottle of water, $120,000 if you wanted to send it to space and back. And it can take over a year or more to do that. In my just thinking through and looking at how the space industry is progressing, it's hard to imagine that it will always be that way. It seems like space should be not a one-way street. And so I'd always been wondering who would work on Earth return. I figured that was this huge market. It's probably the thing that comes after launch in terms of giant potential. Never thought I would get to do it. And then Made in Space got acquired. And I took a 6-month retirement, decided I was going to go back and look at this idea of Earth return, and really wanted to focus on how to build that where there was a huge market potential, not just build another space capsule type of idea. So I looked at the satellite industry itself as a $270 billion market, and what's interesting there is that it hasn't seen much innovation since Sputnik went up. Every satellite is single use. It gets thrown away after its mission. At best, we light them on fire. That's like the solution to space debris, is to burn the trash. It doesn't seem sustainable to me, and so thought there was a there. We started researching really what kind of opportunity existed, really around this question of what if a satellite can come back to Earth after its mission. Seemed like a crazy, very different question than anybody else was asking. Everybody's been focused on how do I just make a cheaper satellite? It's so cheap I can throw it away. We wondered, could you get it back? And there's two things that really stood out. The first was that the satellites today fly for about 5 years. That's their mission. At the end of 5 years, 80% of the cost of the satellite has over 20 years of mission life in it. So huge amount of money is left on the table when we burn these things up, because there's 3 or 4 more missions in them. And then the other surprising thing was there's a bunch of organizations building mega constellations, thousands of satellites per fleet. And when those are all active, we're going to see on the order of 29,000 satellites per year. be sent to space and another 29,000 deorbited. So it's a huge, huge difference than today's satellite operations. And when you take that 80% and multiply it by the 29,000, there's huge amounts of room for improvement. So we started working on how do you get satellites back to Earth. Very long story short, that's a hard thing to do. There's a reason nobody's done that. We had to invent a different type of re-entry system that gets you from space to the ground with precise landing, not just crashing somewhere in the desert. And to do it with a very small amount of mass, because if our satellite was all a re-entry system, then we don't have a business. So we ended up partnering with NASA on a heat shield they've been developing since the mid-2000s that's literally made of fabric and it inflates like an airbag. And it ends up being much bigger than the satellite itself. Partnered with NASA, did a tech demo. They flew a tech demo last year. It orbited, came back, it works. And then the really cool piece of all of this is once we're in the upper atmosphere, we open a paraglider. Different than a parachute, it's completely controllable. The whole thing weighs 2 kilograms, carries a 300 kilogram satellite, so it's very low mass. But we open it so high up that we can still find the landing site. And today we're hitting a 5-meter target. The capsules, like a SpaceX capsule, is a 5-kilometer radius in the ocean. And we're soft landing on the ground. Today, 5 meters. I think we'll get a lot better than that too. So now we've solved all the pieces of that puzzle and been fortunate enough to have NASA and Space Force fund actually all the development of this reentry satellite is now funded on those contracts. So after we raised the seed round, we've been able to focus that money on just building and operating the business and getting some little satellites into space to prove out our operations, but getting the government revenue to really fund the development of the full system.
Yeah, thanks a lot, Jason. David, tell your story.
Yep, so very cool stuff. We're actually highly aligned in a lot of the thesis, but in 2019, I was a lead founding mentor for Techstars LA, Moonshots Capital Accelerator in the space segment. And what myself and my co-founder were seeing was that there's all these cool new space companies coming out with sensors and all kinds of things you can put in space, but none of them build satellites. So they didn't have anything to put it onto. And the only option really is to go to one of the very few, less than 7 big companies out there and beg for some of their time and some of their focus to actually build them a satellite for you, or try to fit your capability into what's called a standard bus. This kind of goes to Blake's comments earlier, where when technology becomes available, it's one size fits all for everybody, and then eventually it specializes and personalizes. So today, there's kind of like, the way you can conceptualize this is there's like, imagine you wanted to ship something, and you went to UPS and they said, well, we have a 10-inch box and we have a 15-inch box, so as long as you can put it in there, we'll ship it for you. And if you don't, you got to figure out how to shrink your thing down to actually fit inside of a 10-inch box. That's called a standard bus today. So it's a one-size-fits-all kind of solution for many people. A lot of the new space tech that's coming online, and a lot of what DoD in particular wants to put in space, there's a time lag on that. And time is the defining characteristic in space right now. And the reason why is that when you're fighting China and you need new capabilities in space right now, you don't want to wait 2 years to figure out how to fit this into that box, right? Second thing for a new space company is most of them are not capitalized to vertically integrate the manufacturer of spacecraft inside their business. It's very expensive, it takes PhDs, it's a very complex process. And there are really no kind of cheap, fast, new satellite builders out there. So we looked at this and we kind of looked around, and just coincidentally, my business partner had been at JPL for the last 10 years, researching using additive manufacturing, 3D printing, to print small spacecraft. We did some kind of technical feasibility analysis of this, and what we realized is that you can print a class of S-class spacecraft, which are kind of the middle of the bell curve of what goes into space, and you can do it very rapidly. You can send new payloads up there, and you can do it on a cost structure that kind of goes like this over time. Because with traditional manufacturing, you have humans bolting all kinds of things on, using their hands, inducing risk into every single satellite that's built, then has to go through this incredible testing procedure to make sure all that human touch didn't actually mess something up. With 3D printing, as you might assume, you kind of just print it, iterate that design very quickly, and then when you have something, you just hit the run button, and you can print 20 of them on a rapidly declining cost structure. The cost structure of the major satellite companies are people like Boeing, Lockheed, Raytheon, those kind of folks. You can imagine what kind of cost structure gets imputed into a single unit, a satellite. And so if you go to Lockheed today, for example, and you're like, I need a 100-kilogram satellite for my payload, and it's pretty nominal, nothing crazy, they're going to tell you that's $20 million, you'll have it 3 years from now, and you can have our JV team to build it. And what we're trying to do is disrupt that dinosaur industry. This is very much like what Blake was talking about when Henry Ford said, you can have a Model T any way you want it as long as it's black, right? And then General Motors came along and said, well, you can have whatever you want. So what we're able to do, and DoD is really interested in this as are new space companies, is actually take a payload or a capability and just wrap a spacecraft around it and then fly that very quickly. So we have customers now who have terahertz imagers, or electronic warfare payloads that have been very successful on airborne UAVs that DoD wants in space right now, not 3 years from now. And that's what this capability will provide. And I think a common misperception is that people think 3D printing has become so common nowadays that it's trivial to 3D print a spacecraft. It isn't. My partner's a PhD in materials science. He's led teams of PhDs doing this. And we probably have about 4 dozen points of IP, and there's little things like the power supply coming into the building, if that's fluctuating, can actually create an anomaly in the spacecraft that you can't discover unless you X-ray it. A common thing that happens in 3D printing today is if aluminum falls on the floor, you scoop it up and reuse it. If you do that printing a spacecraft, you'll cause an anomaly. So there's all these little practical lessons learned over 10 years of hardcore research that we've been able to observe and incorporate into our solution. And what we know is that this isn't being done anywhere else in the world today. The state of the art today with 3D printing is that the big manufacturers will print a bunch of parts and then hand assemble them, incurring all of the non-recurring engineering and all of the risk that's borne by humans touching things. The other part of this is that when you want to do something like this and you say, I want to put my thing on a satellite, you instantly engage with subject matter experts and PhDs for 18 months, going through design and all kinds of other things to figure out how to get a bill of materials, a block diagram, and a design for manufacturing and assembly compliant design to actually execute. We're building a software package around that entire end-to-end process with an abstraction layer on the front end. So we're coding PhD kind of knowledge and bounding the permutations of what goes into actually defining and designing a spacecraft and then automating that with software, essentially. So the goal is to go from 3 years to build one of these satellites to 60 days. Supply chain is a boundary there. We think we've figured out some of that. We think that we can figure that out down to about 6 months. So we'd get a 6-to-1 reduction on time, pretty nominally. And then we believe that launch is going to catch up. What we know is I was in the DoD launch integration facility in Torrance about a month ago, is that every DoD launch that goes up has space available on it, on our ESPA ramp. So there's actually not a constraint on launch. There's availability on launch. It's that the market is bifurcated into people who know how to build satellites, Boeing, Raytheon, and Lockheed, and then way down here, there's a bunch of mom and pops. And those folks are not clearing the testing boundary. So they're falling off of DoD launches en masse. So if you can actually enter the market and print something that's DoD compliant, that's launch provider compliant, and get on there, there's actually space available to, again, defeat that time boundary. All that time accrues to margin is a way to think about it. So that's what we're doing today.
Yeah, thanks a lot, David. Good stories. Really appreciate that. So I'd like each of you to think about what's the world look like in 3 to 5 years. You've been wildly successful. And if you could couple that thought with respect to what does that mean for dual use. So your future in 3 to 5 years, dual use between government/DoD and the commercial world and the impact that you guys have had.
Okay. We kind of see the paradigm kind of like when cloud became available, how cloud was an infrastructure layer that allowed proliferation of a whole bunch of new technology, and it also kind of democratized all of that. So anybody here today can go to AWS and spin up a cloud instance right now. You have to be a little bit technical, but you don't have to be a PhD. We see satellites forming the same kind of infrastructure base across probably 5 or 6 kind of key areas. One is Earth orbit, so a real, as we talked about, explosion of things in Earth orbit. The other one is lunar orbit, the Earth to Moon highway. So I was with General Atomics 2 days ago at Space Symposium in Colorado Springs. They just won an award to put a satellite in the gravity well that's just on this side of the moon that will do space domain awareness of everything in orbit around the moon. So we already know there's going to be constellations around the moon, and the US government is setting up the highway patrol for the moon now. And then also the moon to Mars transit and then Mars orbit. So all that's being planned now. There's a presidential directive to put a human on the moon by 2025. That'll probably be 2030 for a lot of reasons, or somewhere in that distance. But satellites are going to form this infrastructure layer of space. We're going to see this proliferation of technology. And to enable that rapid proliferation of technology, you have to print things around capabilities, not make capabilities fit into satellites. And so I think what you're going to see 5 years from now is a much broader recognition that this is happening. Right now, it's almost like an insider's game. We all kind of know what's happening in space. But there are going to be people on the moon. We're going to see habitats being built on the moon. There are going to be lunar constellations. China is a massive driving force in going to the moon. They declared they're going to do it. And America's one of those countries where if China puts a Chinese astronaut on the moon, a rover there, we'll commit the entire national budget to beating them, because that's how competitive we are, right? So I think that's going to be the big difference, is it's going to be more broadly known that there is this thing happening in space that's opening up a whole new territory for new technology and for the benefit of humanity, kind of like cloud.
Thanks, David.
Okay, so I agree with all that. I'll give like a slightly different perspective on that same story arc. Focusing more on what's happening with satellites, mostly in low Earth orbit, there's one of the most interesting statistics I've seen lately is that since 2018, we've seen more satellites launch and go active in space than the entire history of launching satellites since then. So Sputnik to 2018, less satellites than 2018 to today, and that exponential growth curve is continuing to grow. What that really, like one way that you can think of that is that there's essentially an exoskeleton being built around our planet. And today those are satellites, and that exoskeleton is very much protecting our planet. It's giving us the ability to monitor the planet, watch change, understand how we're changing the planet, make better decisions about that change. And so that it's very powerful to have these satellites there, this exoskeleton there. The capabilities of those satellites are changing. So it's been mostly Earth observation. Now we're watching things like internet and broadband get added to those constellations. Eventually, we're going to see other things happen on those satellite platforms. What equates to is more and more industry starting to exist in space. And I'm a big believer that it's not 5 years from now probably, but definitely in the next maybe decade or 2 decades, we'll see a lot of heavy industry start to move off of the planet. And the reason is that there's some unique aspects of the space environment that you can't find on Earth, or at the very least, it's incredibly expensive to have on Earth. For instance, you have a vacuum for free in space, and a lot of semiconductors and advanced chip manufacturing requires very good vacuum, and you get that for free in space. So maybe we'll see semiconductors manufactured on orbit and brought back. Pharmaceuticals are being developed, have been for a long time on the space station, even in the shuttle. That continues to grow. We have agriculture companies talking to us about doing interesting like seed propagation experiments in space, where you turn off gravity, you get new seeds that get developed. So everything I'm talking about here needs Earth return, and that's why we're excited about this vehicle we're developing. But to the point, Tim, about dual use, one thing we found on the government side is that when we talk about these commercial use cases, what the government's excited about is that in that same mission, there is a dual use capability. So for instance, we can, when we do our return, we'll be passing at very, very low orbits before we return. We can spend 12 hours or more at 150 kilometers versus the 400 or 500 kilometers that a typical satellite is in LEO. So imagine on our way in to return pharmaceuticals that are developed in space and landing in Mojave, we're going to be passing right over China, North Korea, Russia at really low altitudes where a sensor can start to capture some images and not even transmit them over wireless, just fill a hard drive with really interesting data and then land on a military facility, take the hard drives out, plug them inside a skiff and get the data. Not only that, the same vehicle can be used to carry cargo. So you have a down pilot on one side of the planet, you could launch a radio on a rocket, 90 minutes later you've landed the first aid kit in the radio somewhere, and humanitarian aid, very similar use case. So that's what I think, like in the next 5 years, we're going to see space start to become a lot more commonplace in the way both we do things commercially, but also the way the government uses it.
That's super helpful. Thanks to both of you. So on a very practical note, so the economics behind this, how do you look at this from the standpoint of the customers, your margins, sales cycle? I know government's going to be part of that equation. What's your view on sort of the economics of each one of your businesses? That's a tough question.
It's tough. We are early enough on that we're still actually figuring that out ourselves, but today all of our revenue right now is coming from government contracts, just literally the development of these systems. So that's a little bit of a slower sales cycle. But what we've done is we've focused all of these contracts all to be just getting small checks that are part of the bigger check towards getting an Earth return satellite, a satellite in space and return. So getting pieces of that bigger milestone funded. Once we've locked that in and we have, the service figured out, the satellite, we know how it operates, we know how to get it back. We've come up with just really simple pricing, and we've been testing that on the commercial side, and the traction is there. We have lots of LOIs getting signed now with commercial companies. The reason why is, like I said earlier, they pay $120,000 per kilogram today to do this on the space station. We have some that they've signed LOIs that we will charge them $100,000 and they're happy to pay that. But really what we're trying to do is hit a $50,000 per kilogram price point. We found that there's a lot of market adoption if we can get to that price. For us, the value is, this was a really interesting thing that we found when talking to commercial customers, is that almost everybody we talk to doesn't want to be in space for very long. And I'm talking about weeks, maybe a month in space. And today, if you want to go to space, you can take a suborbital flight and you have minutes in microgravity, or everything else is years. So nobody's looked at servicing weeks in space market. That's what we started to look at. And we started asking ourselves, well, if you had to design a satellite that only has to be in space for a month, how much cheaper is it? And it turns out it's a lot cheaper, because the reason satellites are so expensive is because they have to survive years, and it's the radiation environment, the atomic oxygen, all the things the space environment does to just try to kill your satellite. When you're only up there for 4 weeks or maybe 8 weeks, you can use a lot more consumer grade components. They'll last. And we've proven that out through testing. So now we have a satellite design. It's designed actually only to be in space for a month, but it's very cheap to make. And because it's very cheap to make, we actually can produce really good margins on that service. So it's a little like sneak peek at how we look at the unit economics on it.
No, that's great. Thank you. Okay.
And I just do want to say thanks to Kelly and Craig. Highly differentiated from the very first touch. Before we got our term sheet from them, we had 2 tier 1 VCs out of Southern California kind of circling the final stages with us. And these 2 stepped up from day one and did a couple of things that just proactively, without me asking, demonstrated a compassion for founders. You know, one of our core values is humans are more important than hardware, which is also something it's called a soft truth. It's part of the core tenets of U.S. military special operations. And so just a class act, and I'm really humbled and also encouraged to be on this stage with everybody else that's been up here today. For us, it's simple. We know we can be 6 times faster and 4 times cheaper than anybody else making satellites today, period. And when we do that, we can follow a similar model to Blake, which is once you establish yourself in the market, you just keep pulling prices down while maintaining real dollar margins. So we can do things that traditional manufacturing just simply cannot achieve. It's almost a 1-for-1 ratio. If you want to build more satellites using hand manufacturing, you hire more humans. If you want to print more satellites using printing, you put another printing module in. And so some quick characteristics of the market. Terran Orbital went public via SPAC during the SPAC boom. Received a much higher than $1 billion valuation with contextually low orders, $200 million in orders backlog. Lockheed Martin then did a $100 million investment into them. And probably owns about 33% of the company right now. York Space, York started in 2012 with a guy and a telephone. In 2017, 5 years later, they flew their first satellite. In 2019, they had 23 employees, and in 2022, they got a $1 billion valuation from AEI partners on the back end of 3 constellation orders for the DoD's SDA constellations. And so something happened that kind of woke up a lot of people. And that is between 2020 and 2022, the DoD did something they've never done before, and has never been done before in human history. They ordered 204 satellites at the cost of $3.75 billion. And then they said, we're going to reconstitute these LEO satellites every 24 months to refresh new technology. That's why they put things in LEO, because they want to bring them down, burn them up, burn the trash, and put a new capability up there. So that was a huge demand signal to the market, and to us it said, if you can attack that cost structure, deliver the same quality, and offer them a feature and a benefit that they will get out of traditional manufacturing, you can go for it. That combined with the dual use of all the new space tech and all the venture money coming into that space to buy satellites as well is what kind of convinced us. So that's a little bit of the kind of cost structure aspects of our business, vice the traditional.
No, that's great. Yeah, and you touched on something that maybe one of the last questions I have to wrap things up. You mentioned the leadership piece, and one of the themes here is exceptional leadership. Any lessons learned from your time in building and then leading small teams, and then what turns into big teams? But anything that you can share with the crowd here, lessons learned that you can pass on?
For me, it's always been one thing, and that's have enough humility to be the dumbest person in the room, hire people smarter than you, get out of their way, some of the similar things that were said earlier today, but also to be long to hire and quick to fire, because if you're scaling fast, you can't have that drag. That's mine.
Yeah, I agree with that. I agree with a lot of the discussion I've heard on this stage today about leadership and building teams. Maybe just a little bit of a glimpse at how we've applied that at Outpost. I think we built a pretty unique team, a little bit unconventional. So what I wanted to do from the beginning was really make sure that I was the dumbest person in the room, but surround myself with excellent leaders. So we started when we were building out our engineering team, we started by hiring 3 leads for the engineers, so to have a software lead, a spacecraft lead, and a mission lead. And I knew they needed to come in from industry with lots of experience so that they could really train, lead, guide the engineering team. And that worked out really well. We have 3 amazing leaders that came from Relativity, Blue Origin, and a satellite company called Hedron, and also had been at SpaceX. This group had been at SpaceX and Strata Launch and a bunch of other NASA, other interesting organizations. that put in like strong engineering leadership, specifically with space background. And then the unconventional part was we hired the rest of our engineers almost entirely from outside of the aerospace industry. It all comes back to when we figured out our satellite had to be a lot different than a conventional satellite. My hunch was that if I just hired a bunch of satellite manufacturers, they would show up and say, I'd say, how do we make a cheap satellite? They'd say, oh, we could make a $10 million satellite. I'd say, that's not cheap enough. And they kind of like whittle away, and I would never get the cheap satellite I envisioned. So instead, I decided to hire people who have never built satellites before, who would, the first time they build a satellite, it for sure would not work, but it would be really cheap. So we found our senior mechanical engineer at Specialized. He was building carbon fiber bicycle frames. He kind of innovated their manufacturing process for carbon fiber frames. He came in and invented a process for making satellite structures out of carbon fiber, and it takes them about 2 hours to produce a satellite, and it's carbon fiber. So for us, like, reusability is important, because if we get them back, we'd like to fly them again. So carbon fiber makes sense there. And that's like one glimpse of a variety of engineers that have never worked on satellites before. And then in order to bring that together and have them build a satellite and fly it, we, right after we closed the seed, we designed a mission to get a satellite into space really fast. We booked ourselves on a SpaceX launch where actually it flies in June this year. It's coming up. And this was by far way too fast. I think most of my engineers were pretty stressed that I even said this milestone. But the idea was, I said, look, we're gonna treat hardware like software. We're gonna rapidly innovate on our hardware, and it's okay to fail. The idea is to ship something fast, and we're gonna build satellites through sprints, and we're gonna book ourselves on a launch, and whatever prototype satellite is done by the time it's time to deliver a satellite, that's what's gonna fly. And that's very stressful for a group of engineers who are trained that like failure is not an option and stuff like that. But we rallied, and in a matter of like, that whole project started in like early December basically, and so we have a satellite now that's finished qualifications, and it's leaving for the launch pad on the first week of May. So that was incredible. It's a team that's never built a satellite before, but they're, in fact, I still think there's a high chance of failure. So we're calling the mission failure is an option to remind everybody it's okay if the satellite fails. Like I've said, satellite failure is not mission failure. Our goal is to just learn everything we don't know about operating satellites as a team. And so that's been part of our, like, how do we build a team is let's rally behind this joint mission together and get a mission patch and slap it on our sleeves and see what happens.
One lesson for me is that spaceflight is hard. And so I have to compliment both of you for being innovative and finding new ways. And to wrap things up, what's your ask for the folks here? One ask.
Okay, I'm asked two. We're always hiring. I have a few like very high leadership positions. I'm looking for the big one is the VP of Engineering. It'll be probably the most senior position I staff for a long time. So if there's any like really, really great engineering leaders, I'd love to meet them. And then the second is, after our board meeting last month, we decided to open a little safe of about $2 million. A Series A is sometime early next year, but we figured there's a few investors who have asked if they could get in, so we opened a safe. So if you know anybody who wants to join, there is an opportunity.
I have two, actually. The first one is do whatever you can to get involved in STEM education in this country. Be proactive, find things and ways to do that, because our national security, our way of life, and the way of life of much of this planet it rides on that. And the second one is give veteran entrepreneurs a chance, whether that means being a chief of staff or an admin or a business leader do it. I ran away from home when I was 17. I got a GED, failed at everything I've done in my life. But I'm here because people were willing to take a chance on me, not because of anything that I was good at. And I would just ask all of you to pass that on. There's incredible potential out there in our veteran leaders, and all of them deserve a chance.
Thanks, guys. Let's give them a hand.